All right, so the second part of this lesson, I'm just going to kind of go over this with you because you are doing investigation 10. You will need a dice, which I'm sure you have in a board game at home, or there are some online you could probably use. All right, many board games involve an element of chance. This means that when we spin a spinner, roll number cubes, or draw a card from a deck, we cannot know the outcome. Outcome is a result of the event ahead of time. However, we can often find out how likely a particular outcome is. The degree of likelihood of an outcome is called its probability. Here is a spinner, and the face is divided into 6 equal parts called sectors. So each part is called a sector. They showed one of these in the Math Antics video that you just saw. Each sector or part is 1/6 of the face of the spinner. Assuming the spinner is balanced and fair, then a spin of the arrow can end up with the arrow pointing in any direction. The letter that names the sector where the arrow lands is the outcome of the spin. For the questions that follow, ignore the possibility that the arrow may stop on a line. We do know that happens sometimes when we spin, it lands on a line, but when that happens in a game, you have to spin it again. Okay, so if the arrow is spun once, what outcomes are possible? It could land on A, B, or C. So that is what you would put for that. Number 2, which letter is the arrow most likely to stop? Well, we have to see which letter is the most common, is repeated the most often. That would be letter A, because there are 3 letter A's, 2 B's, and 1 C. You should have another stapled set of paper in your packet. You can use that to answer these questions, and you can just number them 1 through, I believe it is 25. Yes, 1 through 25. And you can just use your lined paper for that. All right, so just go through these questions. This one is relating to the spinner. And I'm going to kind of skip ahead. The probability of an outcome can be expressed as a number ranging from 0 to 1. An outcome that cannot happen has a probability of 0. So for this spinner, an outcome that could not happen, it could not land on letter D because there's no letter D. So letter D would have a probability of 0. An outcome that is certain to happen has a probability of 1. So an outcome that is certain to happen, the spinner will land on a letter. That is a 1. It's going to land on a letter. An outcome that could happen but's not certain is expressed as a fraction. So the probability of the spinner landing on B would be 2/6, because there are 2 letter B's out of 6 total. So that is where it talks about the spinner. All right, and then the second part, they have shown the spinner to you again. You're going to keep answering these questions. And then here they have a dot cube. That is a dice. So what numbers are represented by the dots on the faces of a dot cube? You can look at the cube that you have at home. You can look one up online if that is helpful for you. And then answer these questions about the dot cube. The chance of an event is sometimes expressed as a percent from 0 to 100. For example, if a meteorologist forecasts the chance of rain is 20%, the meteorologist is stating that it might rain, but it's more likely not to rain. A forecast of 100% chance of rain means that the meteorologist believes it is certain to rain. Okay. So what you'll need for the next part is a dot cube, which is a dice, and your lesson activity 47, which should be in your book. Let me show you what that looks like. Give me just 1 second to show you what that looks like. Lesson activity 47. Normally have these pulled up. So lesson activity 47 is going to have a table on it. All right, so probability experiment. So your outcome. So you're gonna, the outcome that it's going to be number 1. How many times do you think that it'll land on 1? How many times do you think it'll land on 2, 3, 4, 5, 6? And then you're gonna roll it 36 times, and you're gonna tally. If it lands on 1, give it a tally. If it lands on 2, give it a tally, and just keep tallying. The next time you're going to do 36 rolls using 2 dice. Okay. Again, if you don't have 2 dice, there is probably something online that you will be able to use 2 dice online to help you roll them out. Okay. And you and your parents can do this, grandparents, babysitter, sibling, you are welcome to do that. So here's another picture of what the table looks like. And it explains it again up here. Before starting the experiment, you predict. You're going to make a prediction. So how many times do you think it'll land on 1? Maybe you say it'll land on 1 10 times. Maybe you think it'll land on 2 10 times, and then you just, whatever you think. But the total number is only 36. So you have to keep that in mind. So you can't, all of your prediction totals, when you add them up, cannot be over 36. That doesn't make sense. And then you tally each time the dice lands on those numbers. And then number 19, make a bar graph. This is where you label the bottom, and then you draw a line going up and fill it in to see how many times. So, you know what, let me switch to a different screen, and I'll show you how to make a bar graph for this. And make sure you predict again in your second experiment. So that's the end of this, and then I'll make one